I think we left off here in the initialization function. Yeah, initialize round we were looking at, and we will look. So we got up to here, I think, where we were initializing the goal data, and then for some reason we had some other duplicate position information for the snakies. Right. So we're calling 3 times the same function here, here, and here for all the 3 enemies, and then a different one for the almas. So let's take a look in this one. So let's not break here, but here. And snakies are present in this level, but let's go to a level with that we're actually running, which would be level 1. We have to load it though, so let's load it from the start. Okay, I have to remove this. I mean, there's a sound being played right now, and that it takes a while. I have to see if I can remove that. Okay, so one snaky is already in the level though. That's also interesting, because I mean, there's another one like over here and over here, and the level has stopped loading here. That's also quite interesting. So HL contains the duplicate level initialization working position. That's D26B. Not this one, but this one, right? That's a duplicate for some reason. And we're loading in DE the snaky 1Y position, so that's probably a pointer to all the snakies though, which is D026, which is indeed, so this is the count, and then the pointer of all the 10 snaky informations goes here. So it's probably going to load all this information here in this function. What's interesting though is this might not just be this information, but these actually as well, because there are 3 snakies in this level, and I'm thinking these are XY coordinates of all 3 of them. And let's see, I'm going to skip over this function and we'll see if all these bytes, so 2, 4, 6 bytes, get copied into the position information for the snakies. Now we are missing direction, I think. So we have snaky 1Y, snaky 1C, and its direction, and then snaky 2. So there's 3 bytes, but we only have the XY coordinates here. So maybe the directions would be, I mean, we don't really have to initialize those because that's just random, right? They move, like the facing direction does move at random in the AI stuff. So we probably don't set that yet. So let's skip over and see if these 6 bytes get copied into the correct positions here, which might as well be the case. So we skip over. Oh, yeah. So, and it initializes the direction to 5, which is, I think, front facing, so downwards, I guess. Yeah, so it does indeed copy, and it updates the amount, and it copies 1A2C, 2A08, yes, and 2A18, 2A18, yeah. So this is not just a dupe, it's actually maximum 10 XY positions to copy from the ROM into our working area here, where they can be manipulated. So yes, let's see. Well, we have to rename this though. I'm assuming it's going to be 10 pairs of 2 bytes, as it is 10 positions maximum, because we can only have 10 snakies, 10 skulls, and 10 ghouls in a level, and 5 almas, but that's fine. That's a different function anyway. So how are we going to name this though? We have, so this non-duplicate level is like, well, this one seemed to be reused for multiple stuff. That's why I called it like a working position. But these are like initialization mob positions array or something. So level initialization mob positions. Well, it's going to be mob 1, y and x. I'm going to do the entire array. I'm assuming it's going to be 10 max. That makes most sense, because why would it not be? So let me fill out these first, C, D, and E, so I can change it to 7. That would be 3 then, but let's just do it like this. And that's 0, and this becomes 7. So 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have 10 positions. That becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, and E. Let's reload this symbol information. Okay, now these have gotten a color, yes. So we have 10 positions. Potentially, this might also be a room for initialization data, perhaps. We'll have to figure that out. Now let's dive into this function, see whether it does anything else. I mean, it's going to put the directions on 5 for all 10, regardless of how many there are. That's fine. It's going to update the total amount, and it's going to copy over the correct XY positions in their correct spot, so skipping the direction every time. So we're going to restart, and I mean, it sucks that I have to go better. Put a save state just before loading level 1, which I cannot do, I think. Well, I mean, I can put one here. Save state. Before start. Okay, so now we can easily break here. Okay, 67BA, we're going to go into this one. 67BA. Okay, we got so we got 2 pointers as the parameters for sure, and we have 2E to 8 as well. But we are immediately overwriting those, so that doesn't matter. We're writing 10 in B. That would be our, so it loops here, right? So we have the start of our function here and the end of our function here. And at the bottom, you can see the DJ and Z, which indicates that we're looping like 10 times, depending on the B register, which is 10. So makes sense because we're doing this for 10 enemies. Also, the fact that in the previous function, in the initialization function, there was a different routine being called for the almas, also makes sense because Almas only have 5, and it's going to be this one, I'm pretty sure. Well, yeah, it's going to be this function most likely. They're next to each other, like that makes sense. Okay, so we're looping 10 times, and we're putting 5 into A, which is going to be the direction. I mean, I have to add a column with comments here, so I can put comments on stuff. That would make things more clear. Hi, Kim. So today we're looking at the initialization routine of a level. So preparing all the memory that has to be initialized, as in the XY positions of all the mobs, stuff like that. So it's going to be not that complicated, but I mean, it's going to be doable. Like we've already recognized certain things that goes on. So yeah. Okay, so let's see. So we're loading 5 into A. 5 is going to be the default direction that they're facing. Like the directions are, again, where do I have one? 5 is down, right? 5 is down, meaning front facing, which is what most mobs will be facing when you load a level. Yeah, it'll be fun. It'll be fun to figure out. Good. So we're pushing BC. That's fine. One moment here. Okay. Right, so we're pushing BC on the stack, that's fine, which is now 10. Okay, that's our loop. I don't know why we're doing that. Yeah, I don't know why we're pushing that on the stack. I guess to load it back into, okay, yeah. So we're using the B register inside the function, so we need to keep track of our counter. So the B register contains the countdown for the for loop, and seeing as we have to use the B register within the function, we have to save it, so we pop it onto the stack, and just before we check the loop, whether we have to continue or jump back, we pop it from the stack. Right, that makes sense. So I'm going to double check and look at the DJ and Z function or opcode. And that should reference register B. So that's this one. Yeah, so the B, so it says the B register is decremented, and if not 0, the signed value D is added to the PC. So it's a relative jump, that's fine. So yeah, the B contains the loop iteration counter. Good, so we're loading the value of HL into C. HL containing, that's our temporary storage, I think, D26B. That's going to be this one. So we have our array of 10 potential positions here. We have to index in those, right? So we're loading it in CMB. CMB are separate, so we have to load them separately, right? So we're loading 1A and 2C into our registers here, which we're doing here. We're increasing, we're loading B and increasing again. So now we're pointing at the next one. That makes sense too. So yeah, we loaded 1A to C in B in the BC register. We're exchanging DE and HL, that's fine. We're just swapping stuff around here. And then we're loading C into what HL is pointing to, which, because we swapped, now points up here, right? So now HL contains DO26, which is indeed our first Y position of our first snakey. and we are simply writing the C value, meaning the X or Y, the Y position we got from here. So yeah, C would be 1A then, which would be written in this one here. So we're simply looping and copying. So we're writing C, B, and A, meaning A was the 05 for the direction, right? That's hard-coded. That's so these two have appeared now, and now the 5 is going to appear in the snaky direction, which it did. We're increasing HL D028 to point to 9 for snaky 2, right? That's the first entry for snaky 2. And then we're moving the registers back, HL and DE, which is fine because our source will now again be over here. So we're just looping the pointers and copying the values and putting 5 as the direction. Simple as that. So we're popping our counter, which is on the stack at the top right here, back into B, because B was temporarily used for holding the location value we had to copy. But now we're popping back from the stack. We're putting 10 in there. We're decrementing the B register, checking whether it's 0, which is not going to be. And then we jump to do the second iteration of this function, right? So it becomes 9. And we're jumping all the way at the top of the function. And again, we're pushing BC on the stack, meaning the updated iteration counter. So we're doing this 10 times. Where did the function start? BA. Okay, so it started over here. Let's give this a name. 6, 7. Okay, that's after initialize round. Makes sense. BA, because it's related to initialize round, right? So this copy. How did I name this? Level initialization mob positions. To mob positions, right? I mean, actually this is just initialize or copy mob positions. Finding a good name, that's always hard. Like, I have to convey so much information in like one piece of text. So we are copying from the temporary area into our definitive area, and we're setting the direction as well to 5. And I mean, I need a direction though, and the sucky part is that it just has snaky 1 position or something, so I don't designate this otherwise other than mob XY direction, right? So I mean, I guess I can put it in a comment though. Copy level initialization mob position. I'm gonna make this init and direction, and then I can say this copies into actual positions and sets direction to 5 down. And then this function is executed during level init for snakies, skulls, and forgot what it was. I'm going to escape this function so I can see. Snakies, Medusa. Yeah, we can have 10 Medusas as well. 10 skulls, but not almas. Okay, so it's for snaky, skulls, and Medusas. Snaky, skull, and Medusa. Okay. Oh, this function is right below here. Okay, okay. And then indeed for almas, like I suspected before, it's going to be the function right below, which has a maximum of 5. It's weird that they did that in separate functions, because you can just give the 5. Well, unless this 5 is the facing direction, though. Yeah, it's the facing direction, because again, we're putting y, x, and a into our little array. D2 is indeed the top. So we're doing a different loop thing here. Wait, so here's the end of the function. 67D2 is jumping back to the top of the function. Yeah, so it's comparing to 6 for some reason. There are, I think, 5 almost max, right? So we have goals. Oh, where are the goals, though? We're not doing any... Oh, yeah, we do. Goal data is copied with L there. I'll have to look again at the goal initialization, because that doesn't really make sense. Why they would do that differently. But that's fine. Now we have to name these guys, because these are the... So we load the pointer to the level initialization mob1 position, but I'm assuming this is going to be applying to snakies only, because we load a different value here. So this might indeed be 10 XY positions for snakies, and then we have 10 positions for Medusa and for skulls. Well, D27F, yeah, D27F is for Medusa, right? Yeah, that makes sense. So let's give those a better name then. Instead of level initialization working position X, this is actually for snakies only. And yeah. And actually it is the init position, right? So let me make this bigger. Yeah, because now we have the exact same for Medusa. And I am assuming, yeah, seeing as it calls the exact same function, means that the format, the layout of these values is going to be the exact same for Medusa and Skull, namely 10 XY coordinates, 20 bytes. So I can just copy this and change this into Medusa. And we have to change the addresses, of course. I'm just going to remove the last one. I mean, it's going to be No, I'm gonna put 8, and this is 7F, and then 8. Yeah, that's right, correct. And then we go A, B, C, D, E, oops, E, F, and then we go 9, 0, 9, 1, and 9, 2. Let's see how that looks. Yeah, so now we have Snaky 10X, which is the last one of the snakies, and then we have Medusa 1, and that would make sense here. Yeah, we have now Medusa's first position loaded in HL, and then D293 would be skulls, which would be this one. Yeah, so that's exactly correct. And we have 10 of those as well. Okay, so these are 10 skulls. Let's put 9 here. 3, 4, 5, 6, 9. A, B, C, D, E, F. Oops. Okay. That's also, so those are the next 10. Yep, and that's Medusa 10X. Oh no, skulls. We were looking at skulls. Wait, I made a mistake. Why does it stop? Did I make a mistake? 292, 293, A, B, C, D, E, F, D230. Wait, that's weird. Wait, I'm in the wrong. I'm making a stupid mistake here. D293. Yeah, that's this one. Yeah, which is skull 1. Oh, after F we have wait, D29F. Yeah, after 9 comes A, not 3. Obviously, that's a stupid mistake. Of course. Yeah, now we have until skull 10. What do we have here? Oh, this is gold data. There's something in between here. Which are we missing? We must be missing, well, we have D2A7. Yeah, okay, this is, oh, almas, of course, yeah. So how many almas do we have? Let me double check the amount of almas we can put in a level. I think that was limited to 5 because of them being sprites, right? So let's go here, let's put ourselves an alma. 1, 2, 3, 4, 5. Yeah, and it only allows us to do 5 almas. We do have to figure out the alma initialization data though, because that could be different. So let's see. Let's load a level just before almas in there. So that's 4, I think. No, 5. Yeah, 5 contains almas. So we do level 4 before exit. We re-enable the breakpoint and go into this level 5. We'll break around here. But yeah, so we're loading D2A7, meaning this is alma information. Okay, we already have, well, we have 3 positions though. So 1, 2, 3, 4, 5. Okay, it's just 5 XY positions because this is cold data. Okay, so we have 5 alma data. And now, no mistake with the hexadecimal. We're still in A, 7, 8, 9, A, B, C, D, E, F. That comes B0. B0 is the last one. Yes. Okay. We'll refresh, and these now have a nice color too. And we call the... Oh yeah, I have to put a number here. So copy level, level init, copy 10, because there's a difference between 10 and 5 here, right? This copies into the actual positions, okay. But this is the 10 times, and then 67CF is going to be the 5 times. 67CF, which is this one, loads the direction, copies the data, and then for some reason it does the bounce checking. I'm gonna have to look. So let's put 67CF as a breakpoint, and let's disable the other one so we can see exactly what happens here. I'm going to restart that level, or that state. Yeah, so we are breaking now in 67CF. We're loading the direction, so where do we have to go? So yeah, we initialized all the directions of the snakies, the skulls, I think. Yep, those are skulls. These are medusas, but there are none of these in the level, but they still get initialized to 5, right? So there's 3 almas. So this data has to be put in. Oh, that's also interesting. I don't know if these 8s and OFs were already initialized. So we have alma Y, X, direction, sprite index. So yeah, that's why it's different, right? Sprite color, an unknown, and the second sprite color, and the roll direction. And then, so we have 1, 2, 3, 4, 5, 6, 7, 8 bytes per, like it's a set of 8 bytes, right? Do we have information here? No, we only have our X and Y's for all the almas we have. We have 3 almas, 1 in each row here. Yeah. So we need to jump a couple bytes. Well, CBA are put next to each other, which would mean XY or YX and direction. Is that correct? Where are we here? This one, Y, X, and direction are next to each other. So that's why there's no funny business here. We're just putting C, B, and A right next to each other. And then, so we push BC, and we're loading 6 in there. Let's see what happens. So we're going to take 12 OC, and we're going to put that here. Okay, and then the direction being 5 in alma 1 direction. Okay, let's do that. So that's this. Okay, and now the direction. Yeah, so we put 12 OC 5 here, coming from 12 OC here, and then so we have OC 12 in our BC. That's the XY coordinate. I don't know why we're saving that though, because we're pushing this now onto the stack for some reason, but fine. Right, we have our XY on the stack, and we're loading 6 into BC. We're adding HL. Okay, makes sense, right? Because we are in this position, so we are on the 3rd entry of our little struct, and we're adding 6. So 1, 2, 3, 4, 5, 6 puts us on the 2nd alma Y position, which is the start of the next little struct. Makes perfect sense, right? Yeah, we're adding 6 to our HL pointer. Yeah, okay. So I wonder though, where does our 5 come from in our loop here? So we're popping BC, but we never pushed it unless we did it here. That is weird. Where is BC getting set to 5? So we're loading the 2 pointers and we're jumping to here. Oh, it makes a copy here. I didn't see that. Okay, so we're putting 5 into A and we're copying A into B. So 5 being the direction and actually the maximum amount of loops we have to do. Okay. So this is then the same, but copy 5 level init Alma positions and direction, which is at 67C F, and this copies into the actual position and sets. Okay, that's the same comment. That's fine. And then we have a name for this one as well. So this is these are 2 little subroutines here inside this function, and I think, I mean, we do return. Where would we return to now? Because we're jumping here. Actually out of the function, I assume. Because this is a new function, right? Yeah, probably. Although it does stuff with that too. So let's see. I'm going to loop it 5 times, right? So actually, let's break here and let's just run. Okay, we've done it 5 times. So the data here is set for all 5 almas. Yep. This is first XY, this is the second XY, and the third. Okay. And then we're returning where? 4250. Okay, so we're jumping away. Oh, that completely exits initialize round. That might also mean, because we haven't named this function, right? Yeah, we haven't looked at this function in particular. This might mean that there are other initialization functions available here, perhaps the one before or after that. And it's also right before game loop. Yeah, so we have a parent function that calls initialize round. That's quite interesting because that implies that initialize round isn't initialize round. It's like a specific thing within the initialize, or like initialize mobs. And I think it's going to be that, right? Because if you look, so let's get back to where we are. Oh no, we are here now. Can I go here? Yeah. If we look, what does it initialize? It does power-up stuff. Oh no, it does more than just the mobs though. It does the power-up stuff, the load start position, the exit position, and the mobs. And water flow direction stuff, which we have to look. Oh, we didn't look at this one though. And nor, well, 0402 is the top left position, so that's fine. But DB61 we might have to look at. DB, where is, oh, that's quite low here. Right, was it not this? Oh, yeah, there's no water in this level. So yeah, it was around here, but there's no water. I am going to look at that though, because that's something we have to name. But for that, we need a level with water in it. It probably copies the water flow positions, even though I don't see any function calls. Or maybe it is related to this function, the hard framer and mob counts, perhaps. Let's see. We are going to continue, see where we are, right? I'm going to load a level with water. That would be 6, so we're stopping just before the exit here. All right, so we are here. We don't need this function anymore. What is this? Yeah, that's where we are. No, 6079C is this one. Okay, we don't need that one either. 67E7. That's the return after the initialization function. That's fine too. And then we are here. DB61 is empty. That's this one. Contains no data. That is weird. I would have assumed it had something to do with the water flow direction or with the hard framers, because those are the stuff, that's the stuff we're seeing now, right? Nor with mob counts. Wait, so let's see what happens. So yeah, loading DB61 here. We have the water flow direction array in IY. We're loading 79 in B. 79 was a good number in the sense that it was the amount of blocks or something. Let's get the calculator out. Let's look at 79. Hex is 121, and 121 is so 11 times 2 times 11 over 2. Yeah. So we have 11 blocks, so 11 by 11 is 121. So we have 11 blocks horizontally, and we have 11 blocks vertically. We are starting at 0402, which is the XY coordinate of the top left position here, and we're doing something hex 79 times, which is 121. So we're doing something for every block on the level. Okay, so and it's also loaded into B, implying it's going to be a loop counter iteration variable. Okay, and we're loading the value of that HL is pointing to into the accumulator, and we loaded DB61 in here. Okay, so this assign hard framer function does more than we know, because I never took into account this data that's here, unless it is all this, though. That's also possible. Like if we are looking at tile information, those have like 4 bytes each, so it could include all this too. This actually might be the level data, although it contains nothing after it though, unless this information was copied here though. Like this could be current level data. Now DB61 is empty at the start. Would that imply that there's nothing in this block? I don't remember the level by heart. Let's see. Like we assign hard framer and mob counts. And our loop here, referencing our B register, is checked here. That's very interesting. So these functions might influence our counter, which is at 79, or like our max iteration. So I'm going to skip over and see if here that is reduced to 78 in our B register. Not yet. Not yet. Well, that's also weird. Why would it not be less? Oh yeah, no, the decrement happens in the DJNZ call, obviously. Yeah. So we're doing something for every tile here. Oh, right. So this one is not assigned, but it counts the hard framers and mob counts, I think. Like it loops all the 121 blocks. It checks whether it's a hard framer and all the mobs and increments those. Instead of putting the totals in there, it increment, hard framer, and mob counts, right? And then update working position. That might just calculate what XY position we are at, because we are putting that in 0402, putting that into HL, which we are saving in our initial working position, right? So that is actually accurate. That name just updates that position, and here we count. So DB61 is the current level. We're going to change some stuff and see if we can influence the makeup of the level, right? I'm going to give that a name. I mean, it's map data and it's a pointer. And we are at DB61. So that's now this one. I wonder if indeed the first block here is empty. If that's the first thing that's being pointed at. So yeah, so we have a name for this at least. So let's run. Yeah, it is. Well, I mean, Lola doesn't count, of course, because he's a sprite. But oh, and we're in the bonus level. We're not even in the. I was looking for water data, but it's not going to be water data. It's going to be this entire array of stuff, and there might be something else after here as well. Actually, I can count at those. So we should have 121 blocks times 4. So we have to have 484 bytes, right? So that's what our end result should be. We start at DB61. So we have DB61 is our starting pointer. And can we convert that here immediately? Yes. Plus 484. And then this back to hex. 566 is DD45. And that would be here. And exactly after that, it starts with FFs. So yeah, that's going to be the end of the map data. So now let's force this. I'm going to load state. Well, no, I need to load a state where we're not spawning in a top left position though. And also I need to know how to right, I need to calculate some stuff here to see if I'm in the correct position. So we need to put, for example, B8, B9 and BABB. I'm thinking it's going to be, yeah, let's look in the sprite in the tiles, and let's see. So B8, B9 is 184, 185. Which is a skull. So 184, 185, 6 and 7. B8, B9, BABB. So they're not next to each other because, of course, this is just like a horizontal listing of all the tiles. But there are like 2 tiles horizontally and 2 tiles vertically for every mob, right? For every block. So we have the top 2, and then we have to go all the way to the right, and then back from the start all the way to the right until here, and then we have the 2 bottom ones. So the difference between that should be 11 blocks, so 22 tiles. Does that make sense? Starting from dbc3 plus 22 hex, which is 16, and 4 makes 20, plus 2 is 16, plus 6, so it's 16. Is that correct? I'm gonna have to try it. Well, 22 is no, 22 decimal 16. Yeah, 16 is 22, plus this one is dbd9. Is that this one? Yes. Okay, so we need to add 16 hex bytes, or 22, of course, to get the second tile. Okay, so let's try this. And let's take as values. I mean, I can look at them here. Well, no, they're in decimal. So we need B8, B9, BA, BB as our skull things, right? So what we're going to do is we're going to go load a level, and we're going to add an extra skull. Here. Wait, I want to break here, because that is just before we do all this stuff. So now the top level position is taken by Lolo, so this is going to be Lolo, and this is going to be our extra skull. So our numbers were B8, B9, so we have to put BA, B9, and then this plus 22 is db63, db663 plus hex 16 is db79, which would be this one. That becomes BA, BB. So if everything works now, we have Lolo in our top left position and a skull right next to it. Let's see if it works. It does not, obviously. So that means that might be because I haven't got any other skull data in the other array. So it might be better to put like a block there or something, which would be, yeah, a mob would be wrong to put there, I think. So that would be 116. Which is 74. Where is our block? Oh yeah, 74, 75, 76, 77. So that's a block. 74 is the start. So let's redo that. I wonder if it'll work though. Maybe we are too late already in the when we're breaking here to add a block here. I mean, we'll try, right? Yes, that does absolutely work. And is it a functional block now? Yes, it is. So this is indeed our map data before we load. Very good. Now to see where are in the ROM, right? There are 105 or more levels stored, the bonus levels too. To figure out where they are in the ROM, we can see what writes here. That'll also be interesting to look at. But yeah, we can't add mobs at this point. That's not necessarily too late, but we need other information as well. We can't just add a skull here and then without adding its XY position elsewhere in the initialization data. Yeah. Let's see. So we have this one. Are we missing anything else in our initialization function here? Where are we starting here? Oh, we are calling something that we didn't name. Bullet count, level timer 23. 23 would be the amount of seconds, which is 35 seconds. I guess that's a bit low. I'm not sure why it's only 35, but fine. Current bonus level is checked. We have our power-ups, 3 of them, which we integrally copy with L there. Okay, then Lolo's start position, facing direction, bonus level is again checked. Exitor, because we don't do an exitor on the bonus level. The bonus level finishes when we kill all the mobs, right? Or the timer runs down. Exitor position 8 is put into A. Oh yeah, 8 is the tile ID of the exitor. That's fine. We're loading 0402, which is 00. D97D. Did we not name this? No, we do not. We were working here. Okay, no, we were working here. So D97D is also something interesting, which is also an array of stuff that perhaps gets copied. So, and again, yeah, this is again 0402, so in 00, the first block, and running for 79 hex times, which is 121. So we're doing again something for every block on the level, but this is completely empty now. Maybe I'm too late. Let's see if that gets set before. Okay, no, I have a suspicion this could be water related, so let's see whether it's that. It's going to be level 6, I think. Yeah, so we'll stop at 5 before exit, and we will exit. Wait, I have to break at the correct point, though. I don't think I'm doing that, which I indeed am not. Crap. Okay, I have to go back to my... It sucks that I can't really search in this one, though. Okay, I have to search in this one. 6716. Initialize round, and we were looking at... Oh, for here, this one. We're loading the state 5 before exit, and we are exiting. And we have nothing in there. And we're calling it unknown function here as well, though we haven't figured out that one yet. And we're updating our position. Okay, that does make sense, but we're doing something with something. We just haven't figured out what exactly. Let's load the... Well, it's not going to be the bonus level, though. Would it have something to do with power-ups, though? That's also possible. Oh yeah, so this loads the bonus level. No, I need the level before the water. We still haven't looked at the water because I need to do this and then break. So yeah, timer runs down, and now we load the level. Yeah. Oh wait. I mean, it might not be relevant yet because this is the special word stuff, right? And we haven't broken yet. So let's continue. Okay, so that's just get reused for something. Again, completely empty though. What could write here? That's weird. So we looked at bonus levels, we looked at water, we looked at a regular level. I mean, I can do them all though. Yeah, it's not water related. Let's load something. So we did the first level, right? Yeah, this doesn't have anything. This doesn't have anything. Nor this. I mean, it's the same size of a map. Something has to be on there. Okay, so that was level 3. Nothing to do with goal. Level 4. Nothing in there. Nothing to do with Medusa. Nothing again. Nothing to do with Alma. Again, nothing to do with the bonus level. Yep, still empty. Okay, we did the next one. Level 6 before exit. So level 7. Nothing in there. Do we have more? I don't know. 7 before exit. Yes, we do. Level 8. Ooh. Ooh, here we are. Here we are. 14, 15, 16, 17. Let's see what tiles those are. Might be arrows, perhaps? Arrows or bridges or something? Let's see. Okay, the tile viewer was open. 14, 15. That's 16 and 4 is 20, right? So 20 decimal. Yeah, arrows. These are arrows. Yeah, because the arrows go all the way up till 31, which is 20, well, 19 hex, I guess. No, 2 times 16, yeah, it's 19 hex, right? Although we do see 1C and 1D here too, though. What is 1C? That's 28. Oh, no, that's still... No, I was mistaken. Oh, yeah, 2-0. Yeah, okay. Yeah, so these are arrows. This is arrow initialization. Let's see. It's weird that it has to be separate, though. Like, it has to do something with... like, we haven't looked into the arrows much yet, but that's clearly what it's doing. So we're gonna have to rename stuff because we have 2 level init map data pointers, one being the arrows and the other one being like just objects, not mobs. Everything but mobs and arrows. So yeah, we have to rename that. So level init map data pointer should be inanimate objects pointer. Because I mean we didn't check, but like the mobs are probably not going to be inside this array here, right? So so let's put D97D in there too. Also, let's put the size equals 11 blocks, 11 times 11 blocks times 4 bytes per 4 tile bytes per block equals so 121 times 4 was 484. So level init map data arrows, arrows pointer. Okay. And then this function is going to copy our data of our arrows into our working area, which we don't have either. Wait, we didn't check what it actually... Oh, no. So, yeah, we're loading pointers and we were assigning hard framer and mob counts. So, yeah, so the second loop did updating of hard framer count and mob count. And this function counts, I mean, it does something with the arrows. That's going to be in this function. So we'll have to figure that out, what exactly it does. Okay. So yeah, let's go in there and disable this one and go all the way here and go in this one. Let's break here. Okay, small function. D1C9 is being loaded. D1, that's going to be the arrow data. Yeah. Here we are. C9 is going to be assumably 10 XY positions or something, and direction of arrows. So 1, 2, 3, 4, 5, 6, 7. Okay, so we have 8, 9, 10, 11, 12, 13, 14, plus 7, that's 21. Okay, how many arrows can we put in a level? Let's look at that. Because that's going to be our limit here. Yeah, because there are arrows in this level, so it's good that we have that level in our save states. So we're going to get the keyboard out. Where's my keyboard? Oh, here it is. It was already visible. We're going to select the field stuff, and then we're going to put arrows. And I'm assuming like 7 or something. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait, this is weird. We can have as much arrow as we want. How's that gonna work? Weird, because our array stops here, right? These are treasure positions. We have 4 treasure positions. Exit door. Okay, so we have a limited amount of space here, though. 2, 4, 6. I mean, it's offset, of course. 2, 4, 6. Well, no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and maybe the first is count. Okay, let's just see what it does. Let's start with a normal level, and let's see. Right, so we are in level 8. No, we need to be at end of 7 for it to trigger. Have to re-enable level end of 7. And then let's see here what actually happens. No, that's just exit or position. let's see what gets put in this thing here. Actually, I'm gonna let it do its thing first and see what is input here. Why are we breaking? Oh, we're not. Oh, that remains empty. That is interesting. Maybe it only changes when we actually change an arrow, because that's what the power-up is for. The power-up allows us to change an arrow. Because now it has its direction implicitly set from the map, and I think if we change it, let's see, so nothing has appeared yet. I'm gonna have to take care of this skull though. So nothing has changed yet. I should have pushed that block. No, so that's not even touched. So I might be looking at the wrong information here. Yeah, so these bytes here, these zeros are not touched. Fine. Let's go back to our level loading. Let's see. What does this do? Let's go look at our source 2, which was D97D. I mean, it's quite far away. Okay, so D97D, is it this one? No, that's the power-ups. Start position, it's this one. Yeah. Oh, also, it's not going to be, well, oh yeah, no, it is errors. We looked at the tile IDs, right? So good. Let's see. We are pushing some stuff, that's fine. We're loading A into C. A is 0. That's probably our, well, no, B is our loop iteration. We're adding some stuff, comparing. Oh, we're calling different functions based on the results here. So comparing to 4, comparing to 16, comparing to E8, which is 232, which is, oh, that's 232 is this position here. So not sure why we're doing that. Okay, we're not doing anything. Oh, okay, but we're looking at the first block though. So I'm assuming when we arrive here, then we're actually going to do something. So let's go to the next block, which also does nothing because we're like still in the first area here. So let's see, where do we jump away? Was it this one? No, right? Okay, so we're incrementing. So I think we're counting arrows though, but yeah, sure. Let's see where we jumped away. So not this one, not this one. So that will be the second. Oh yeah, it was this one, I think. So let's break here. Right, this one jumps us to 680b, which is the end of the function. That's correct, right? Yeah, so let's just run until we get to not jump and to be over here. Because that's at that point we're going to write something in D1C9, right? We're incrementing that. And then D1CA is also involved, which would skip to the next one, I think. Duplicate working, okay, sure, okay, let's see. I'm going to disable this one and continue. Okay, we do not break at all. How can this be arrow related and we do not break here? That is very weird. I mean, it makes sense because we don't see any data being written in these bytes though. So there must be a condition, something special with arrows that we're not seeing yet, even though there are arrows in this map, unless, of course, we are not looking at this map. This map could start here as well, right? This could be something completely different. Okay, let's get the difference between this one and this one, because the next map, the map data starts here. So this should be a fixed size, being 11 by 11 blocks times 4 tiles. So let's calculate the difference, see how much space we have. So D97D, I don't know if we did that already, D97D, apparently not. So 484, so D97D hex, let's convert that to decimal. No, you have to do it though. Convert this to decimal, add 484, and then back to hex. DB61, oh no, that is correct, because yeah, we're doing one base, right? Yeah, I did start here, and then yeah, we have to subtract this one, so we have to start from 0. So yeah, that is exactly a map though. It is the map of arrows, but why does this not get accessed, or like why does it not manipulate anything in this function based on, even though there are arrows in there, right? That's very weird. So we can see what we are comparing though. Let's reload. So what comes in here? So A, let's see what gets into A, because A gets loaded into C. That's fine, we're taking a backup, and we're ANDing A, of course, with FC. And I'm comparing it. Again, that's with the A register, I think. So we're not doing these calls, perhaps, are we? So let's go in, comparing. Yeah, we're not doing these calls. Again, okay, so we have to, that's why we made a backup of A, because we're loading that back into, from the backup back into the accumulator, and then we're ANDing with F0. So again, so we're not going to call this one either, that's fine. Again, load the backup and comparing it to 32, or no, E8 was 232 or something. Oh, and that's the end. Yeah, because we are going to jump here. So now we still have 0 into A, and again, like it keeps, like I'm looking at the accumulator here, and it's still A, and that's the value we're actually checking though. So let's see what puts something in the accumulator, because that doesn't make sense, it all being EA, unless when we are over an arrow. Yeah. I think, yeah, it's 14 now, which is this one, I'm assuming. And so now it does something. Okay. So yeah, okay, so we were looping all the blocks that didn't have an arrow on them, and now that it does, we can see something else here, right? So 14 hex is being loaded now. Let's see what it does. So we're doing 14. Let's look at the ones and zeros. Okay, so that's 00101. Starting from the right, and we have FC. So we're ANDing, we're dropping the 2 bottom bytes. and we're comparing that with 4. Okay, so we're dropping the bottom 2 ones, and we started with 14, right? So that does do nothing. 1, 2, 4. I mean, it's compared with 4, and that should be a true, right? So let's see whether we jump in this function now. Or we don't. I mean, it's comparing it for exactly. This is more than 4, I guess, right? 1, 2, 4, 8, 16. This is 20 still, right? Okay, and then we're ending with F0, which is, of course, just the one that remains then, right? Oh, yeah, this is going to work. Because, this jump should be taken, I think, or this call. Because now we have 14 here. We're dropping the 4, comparing it with 1, 0, which is correct, which does work. And this one should be called now, 6, 8, FD. Okay, that's way down there, so let's go there. Yeah, now we're here. Oh, it's an update function. So this just puts, okay, this puts the arrows in its place in the actual map, or updates the tile, I guess. Maybe in our map data, we do not have the correctly rotated arrows, perhaps. Or are they even in here? I mean, I don't see 14s and 15s in this one, though. So for some reason, the maps are like stored separately, as in you have multiple layers. Like the mobs are stored in a layer, the arrows are stored in a layer, and then you have just the inanimate objects are stored separately. That might make sense. So yeah, we're just updating the tile in this function. So yeah, we're loading our working position, and we get probably, yeah, C contains 14, right? So we're loading that into A, and we're updating that as a tile position. How are we going to name this? Also an interesting one, D1FF here. We don't know yet. But yeah, 68FD. We can name this apply tile to working position, because we're loading, yeah, update tile. Yeah, well, it's 4 tiles, right? It takes 14 from the C register, 15, 16, and 17, because they are in order, of course. We go look at the tile viewer, 14x, that's 20 decimal. Yeah, that's this one, so that's top left, top right, bottom left, bottom right, right? So they are in order. So we only need to pass the first one, the 14, and it'll add, in the update tile position, it will add 15, 16, as 14, 15, 16, and 17 as well. So this apply tiles to, wait, so we're applying the tiles of the working position to the map, right? I think that makes sense. And then we're going to have to see what D1FF does. D1FF. So the accumulator, well, no, it might change though. Let's do this function. So we have C into A, yeah, so A becomes 14, being the tile we have to apply. Then HL contains the pointer to an XY position, which is our working position. We update the tile, we knob out A. Oh, and we put 0 in D1FF, but it's already 0, so I don't know what that does and why that would be. I mean, it's always going to put 0 here because we're XORing out A. That's going to be difficult to figure out. Okay, so we return. Yeah, so we, oh right, if it's 4 we apply, so what do we give then? So 16, right. So it compares to 16, and that makes sense, right? Because 6 or 10 is 16 decimal. If we go look, yeah, so that's the start of the arrows. So this one only does arrows. That does make sense. So if it's an arrow, it calls this. And it compares it to 4, which would be, that does make sense too. So we're ANDing. That's quite clever though. We're ANDing, like we're dropping the first 2 bits, right? Because we're ANDing with FC and we're comparing and seeing whether it's 4. Those are, so this is used for bridges and for arrows. So this function is an update bridge and arrow tile function. Meaning, oh, and E8 as well. Okay, what was E8 again? 232. Is that also something? Do we go this high? Yes, we do. Oh, that's that ring. I have no idea what that is. Is that a respawn position? I can add that with construction mode, but I don't know exactly what it does. That's been too long. I mean, I might find that in the manual though, in like the walkthrough thing. So yeah, we're also not applying a tile, because if it is the respawn position, then that would make sense. We don't need to update a tile, but we need to write that somewhere though. And that's why we don't break here, because that's a respawn position. Okay, so that might explain also what these 9 or a couple bytes are. These could be the respawn positions you put in the definition of the map. Yes, that's probably what that is. I'm going to give this a name, 67E8. Wait, X67, we have 67E8. Okay, that's this one then. 67E8. This updates the tiles of bridges. I mean, it does 3 things though. Update tiles of bridges, arrows, and stores respawn positions. That's conditional. We're going to test that now, whether that's the case. I'm going to leave this breakpoint and see whether our respawn positions do end up here. Also, so we'll have to see how many we can add to a level. So let's do that now. Okay, we don't need to break. We're going to load the construction mode. So this is the, I think, the respawn position. Let's see how many we can add. 10. Very good. Let's just play this level and see whether we get information here. Okay, we're not there yet though. We're still running this function, and we do break like in where we expect it to break. So D1C9 is going to fill D1C9. So we're loading D1C9 into HL, that's fine. We're increasing the value, so we're going to put a 1 here. For some reason, oh, that's the count. It probably counts the respawn positions. Because what I think happens is it uses them up. Like if you shoot an enemy out of the stage, it respawns it at the first respawn position, and then the next time you do that, it takes the second one, if you have a second one, of course. So we're increasing, we're putting a 1 there, which is probably the count. Does that make sense? Do we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, it's going to be 10 XY positions. Simple as that. Is this contained in our little array here? Wait, where are we? Oh, so this is the map of the inanimate objects. Oh, it's not in this map, so it might be elsewhere. Oh no, it just copies the working position. Yeah, that's brilliant. Of course, we don't need more, obviously. So it's just going to copy our working position. Yeah. Into those position, into those in this array. Yeah, so next time, so now I'm gonna run and it's going to put 0204 in there. Yep, and now it's going to be, what is it, 0208, I think, in this one. When I continue again, yep, and our counter incremented as well. Okay, so we're gonna name these. This is D1C9. Respawn positions count, and then we have CA is then respawn position 1Y and X in B. We have 10 of those. Wait, so that's C and D. I'm gonna, because we have to get a new thing here. 2 and 2, and this is going to be C, D, E, and F, and then, oops, and then we can do this easier, C, D, E, F, and then we need to do D at the end, and let's copy 4, 5, 6, 7, 8, 9, 10. And we go D and then, okay, just count. A, B, C, D. D1, DD is the last one. Yes, that's correct. Reload, and these are known now as well. Yeah, so if we continue, well, it's going to do that for 10 of them. Yep. 9, 10. So we're gonna, well, I can't try it because the skull is gonna activate and I probably won't be able to shoot it. Will I? Come on, it's gonna attack. Yeah, okay, never mind. I mean, I still suck at the game though, so yeah. I think that is everything that this does, yeah. Yes. I do want to try it though, whether those are indeed the respawn positions. So I'm going to go back to the construction mode. I'm going to put like 3 respawn positions here. I'm going to put a couple more hard framers with bullets and a couple more enemies and see whether they are indeed used up. I wonder if they were going to be, like, what's going to happen with the respawn positions. Where are we here? Yeah, whether it counts them down or something. Let's see. So let's play this level. Oops. Okay, I'm only gonna pick up those. So I have 6 bullets. Let's do the first one, and that one should appear now in the first position. What changed here? So we still have 3 respawn positions, and these didn't change. So let's wait until it comes back. Oh, that's not. Oh no! You have to block the position. I'm gonna give myself way more bullets. Yeah, you have to block it from respawning. That's the mechanic in the game, right? Yeah. So yeah, now it can't respawn here. So now it has to look one up in our array here. So we have 3 respawn positions. Ooh, this one changed here. That's interesting. Okay, we still have 3. Okay. So let's see what happens if we do the second one now. So now it should take the next position, right? Which it does. I'm looking for the index. Like, wait, does that mean then if I... So I'm going to liberate his original position here for sure. And I'm going to remove this one again. Where is it going to respawn? Yes, its original position. So is it as easy as saying, as looping all these respawn positions, seeing whether they are blocked or not? And if they are not blocked, just respawn there. And that would be then explained by, if I again block this one, does it come in the first position or in the third? If it's the first position, then it just loops the array of possible respawn positions and takes the first one. Yeah, it takes the first one it can put something into. So there's no tracking of which one has already been used. It's just, it loops them all and see whether they are available and then just puts them there. Okay, so that's figured out. Very good. Wait, where is my init function? Do I not have an init function? Oh, initialize. Okay. 6716. Oh, I could have gone here too. So yeah, this is our initialize round function. We were looking at something we didn't have, which was around here, I guess. Oh no, yeah, the arrows, right. Oh no, it was the next one. Update tiles of bridges, arrows, and stores the respawn position. Okay. It's weird that, so we have another loop here, right? So we did a loop with arrows and bridges. So this would be arrows and bridges, I think. Wait, let me level init map data arrows. This would probably contain bridges as well. So let me load a level with bridges. No, no, not the arrows. I want, yeah, of course, yeah, this is the one. Let's load a level with bridges and see whether that information is in there too. Okay, so 8 before exit, quickly. Okay, now we go look at our map. This is the one, yeah, map data arrows pointer. And let's see, yeah, it was 4, 5, 6, and 7, and yeah, this is 4, 5, 6, and 7. So yeah, it not only contains the arrows, but also the bridge data. Level init, map data, arrows, and bridges. Okay. And then, okay, this can be a little bit smaller. And then we do the bridges and the arrows and the respawn positions. Then we do the inanimate objects like the walls and stuff. But it's strange that it also calls for the water flow direction array. So we have to look into this function again to see whether it does something other than the hard framer count and mob count. So yeah, because IY contains CE1E, which is a bit up here, quite a bit, CE1E, CE1E, which is the water flow direction array. It would help if I got water in the level though. Well, water with actual like moving water, not this is all still water, I think. So let's load level 5, I think it is. I'm going to re-enable and load just before 5, I think. No, it's 6. Yeah, it's 6. Oh, was I wrong? Because this does not contain water flow. Huh. Or does it happen after, perhaps? Is this a target? Wait, so I'm gonna jump after and see. Wait, no, I want to disable you. This did get filled in. Oh, crap. Stupid bonus level. Yeah, my mistake. It's at the end of the bonus level. Okay, that finished. And now it should contain water direction data. Unless, again, it gets filled in thanks to this function. Yeah. Okay, so this does indeed also fill in the water information. So it assigns the hard framer and mob counts, but also the water flow direction data. So yeah, we are looking at, so we're comparing again against tile indexes, right? So if it's this tile, then we are doing like incrementing the hard framers. This might be interesting. Amount of snakies, almas, skulls, medusas. Yeah, and then we return, I assume. Amount of calls. We call and we return. So we have an unknown call here. But yeah, it's probably either D1FF again. Here we see this one again though. That's interesting. Yeah, we have an unknown call here. Comparing it with 60. Let's see what 60 is. That's 96. Oh, okay, I didn't sort. 96. Is indeed water. Yes. So this this function 693c is going to copy the water direction stuff into this in this array, the water flow direction array. So yeah, let's go here. Okay, 693c starts here. Okay, short function, that's fine. Wait, did we not break? Crap, I wasn't there. Oh, it does it. Okay, it's doing that for every tile, right? Is it? Yeah, it's looping all the things again. I don't know the level by heart anymore where there was water. I think we're still at the top here where there isn't water. So yeah, we're not going to do anything useful here. IOI CE7C. Oh, so we are dropping values in this one already though. Plus 0, 1, 16, and 17. That's... Oh, yeah. That makes sense. That's 22, right? 16 is 16 plus 6. Yeah, that's 22. Yeah. So we are adding tiles here. Well, no, it's... Oh, we are applying these directional values to all four tiles consisting of one block. That's why it's plus 0, plus 1, then plus 22, and plus 23. Right. So we can add that as a comment to water flow direction array. Okay. This is a map of the direction of water. Oh, I already knew this. 44 bytes, 22 pairs of identical double directions per tile. No, this is simpler than that. Well, it's a map of the direction the water tiles flow. Each tile position. No, each tile gets a copy of the direction, because I guess you can do half flows then for some reason. So 4 tiles per block means 11 by 11 blocks times 4 per block, 4 tiles per block, equals 484 bytes. It's simpler than what I wrote. Right. And then we do apply that tile as well to the working map. Okay, I'm gonna jump a bit ahead. Right. Load 5C into C. Okay, that's fine. And then we're putting 0 in D1FF again. So I'm going to look at D1FF, and that is still 0. So I don't know what that does. Okay, I'm going to need to take a 5 to 10 minute break. I will be back. All right. So 693C, we looked at, right? Yeah. So it loads the water tiles into the map and also fills in the water direction array. Because that's where was this? Here, right. So this is our water flow direction array, water flow direction array, and that gets initialized in this function. You go away. Okay, so that one is no now as well. And where were we? Yeah, here we were. Which is in the assign heart framer and mob counts, and I mean heart framer and mob counts, and init water direction array. It's weird that they combine these function or these functionalities in this specific function though. Like that's a bit weird, but sure. So we can remove this one as well. And we're not seeing any, well, the D1FF is here, which we're always setting. Oh, no, we're setting this one to 1 now, here, where we're counting almas. Could this be for sprites or something? Because almas are sprites, I think. Yeah, I think they are. So it might do something different based on D1FF, but it's like a variable that gets set like for a fraction of the a very small amount of time within a level. So I'm not sure. Yeah, so we're counting stuff. 688D, that's just down here. Okay, that's fine. This one's also interesting. 68DC. That's here. I wonder what this one does though. I mean, it could have something to do. Yeah, it has something to do with goals though. Okay, but let's go back to our initialization function. Where are we? Okay, yeah, here we were looking at these guys. These can go. And have we, do we have another unknown in this function? I don't think so, right? So we're copying 10 medusas, 10 skulls, 10 almas, right? We are copying 5 almas, and then we return from this function. Okay. So we are here. Let's skip out of this one and see where we end up. And go back to level 1. Okay, everything is drawn. Well, not everything, because the last row isn't drawn yet, but that's fine. And let's see where we end up. Right. Now, this will be interesting to know where this one starts. It could start like here, because we have a halt here. That's a weird one, unless that's a conditional halt, 4241. I don't know. So we'll have to see where we break. I'm gonna put a couple and see if we do break somewhere in this area, so we can figure out the start of this function. Always interesting. Okay, it just starts here. So these aren't related then, I guess. It's also a bit weird, unless we jumped to here from higher up though. Not sure. Unless we can, oh yeah, the game loop is here. Oh, does the game loop start earlier? Because of course the game loop is defined by us calling the game loop, like looping at the end of this, right? We're jumping to game loop here. So this is the infinite loop, of course, but this function might start before that though, because it just runs through here. Like it's not, I mean, it even loads A into D219, which is an unknown, which we're setting to 0. And that's in our main memory here, right? D219. Yeah, this one gets set to 0 for some reason, and then we start like the game loop right here. But it does make sense that the loading of the level is like right before the game loop. That does absolutely make sense. Question is, are we jumping from here from before, or is this like, this is weird too though. We have a conditional jump to 4299, which is like in the middle of the game loop here. 4299 is like type B exit treasure collision check. That's weird. But let's assume that this is the first function though. I'm gonna call this load round then, just as a temporary. Right, just above the game loop, load round 4248. Well, question is, do we have so we have BC in the accumulator. I would have hoped that was 01 or something, as in the number of the level, but apparently not. Let's see what 619F does. 619F starts here. 619F, and where does it stop? It jumps. Okay. So let's go in. It loads 1B00 into HL. Is that something? That's quite low though. 1B00 could be the map data though, but it's very, very low. 1B00 is here, and that doesn't look to be map data. Okay, we're doing a BIOS call. Let's look up what that one is. Oh, I didn't save that one. Uh, 56. Oh, fill VRAM. This could be a blanking thing as well, because we're filling the video RAM with a value. A would contain D1. That's also interesting. What could that be though? What could be D1? Let's see. It's going to be a tile, right? A tile index. So let's see what's in D1. Is 209. Oh. That's very weird. I mean, I would have assumed it was like screen blanking or something, but weird. Or is it? It still has to draw this here though. Yeah. Are we still looking at this 1B00? Wait, no, that was documented here, right? So BC. Okay. The length of the area to be written, sure. And HL is the start address. So 1B00 in our video RAM. 1B00, that would be here then, and we're writing quite a bit though. So we're going to write D1s all here then. Let's see if it works. I should have. I mean, I did jump over though. Don't know where I am now. Because now it's right into ports. I mean, it shouldn't have jumped in there. I didn't. I did step over, but apparently, can I get out? Yeah, no, we're too far away. So back into 619F. So let's break here and do this one away. What's this one? No, this one can go as well. So yeah, this one we have to take another look at. Yeah, it doesn't jump, so I can't return. So I'm going to break here as well to see what this area of memory does. Reload. Okay, so now we're half drawn, sure. I'm going to run and see. Oh, it happens multiple times. It breaks multiple times. And we don't even end up here. So that's a different function then perhaps because we're jumping. Do we have something on the stack perhaps that we can return from? Let's see. So we're gonna have to wait here. And no, we're gonna restart here. So we jump in this twice though. That's also interesting. So we're jumping to the BIOS call. Do we have something on the stack? 412F. Is that where we originally were? 412F is here. Okay, so we're in a different initialization function, I think, although we're seeing lots of show main menu. Oh, well, that might not run as far down though. So our stack points to 412F. Well, as in the return value, I mean 412F here. Let's do the next one. And now 424D. Okay, so there are multiple things that call here. 424D. Do we recognize this? Yeah. 424D is where we indeed were in our load round function. So this is the one we are actually looking at. But yeah, that show menu function apparently calls one too. Okay, so this is the one we are actually looking at now. And then we were looking at address 1B00, but we don't see anything written in there though. Oh yeah, and we're jumping and we're not, like if we continue, that doesn't change at all here. But I mean, I'm going to ignore that because that's just a BIOS call, but who knows what that does. Like, that's fine. It fills the screen or part of the screen with D1. I don't know exactly what that is. That does mean that we can't name that function though. Yeah, because that's the function that's being called. Like it's a reset function of some sort, but I don't know why D1 is getting written into the video memory somewhere. That's a bit weird, but fine. Let's look at the third one here. Well, let's straightly go there, 6BA0. Let's see what this does. Okay, this calls lots of stuff. This also seems like initialization. Now, where were we when it came to sequence here? No, I don't want you to, I want to be here. Yeah, so this happens after our initialization though. Let's see what data we see. So yeah, the level is semi-initialized. Okay. So loading 9287 immediately, that's fine. That could be a pointer to the function 9287. And that's a hard-coded value, and we're calling something, of course. This looks interesting, but what's it gonna do, right? So we're gonna have to check inside these functions. Call this one. Okay. Immediately jumps, so we're loading C000 into DE and jumping to another thing far away. And what's the X thing? I don't know what that means. Exchanges the 16-bit contents of BC, DE, and HL with their prime equivalents. Okay. So all these are going to move in the other ones here. Yeah. Well, sort of, at least. And again, I mean, that's a weirdo, but sure. HL points to 9287. That's what we were looking at here, right? 9287, sure. So we're loading a couple of values. F8, we're loading 2 of them at least, 3 perhaps. And comparing it to B, that's weird. So yeah, we loaded F8 90 for sure, 0F in A. We're adding it with C, comparing it to B, which would be the second thing here. If it's Y, it could be an X coordinate, not sure. And then we're jumping one into B, like this is complex. And we're looping. Okay. And now we're pointing at 928A. Are we in ROM here? Yes, we are. So the easy thing to do is just remove that function and see what we get, right? I mean, this entire function. Because now we're loading stuff again and calling weird functions again. So we're loading a couple of hard-coded values and we're calling 6p46. Yeah, which then calls a 5c, which is a BIOS function. Block transfer to VRAM. Okay. Could this be, well, no. I was going to say map data, but probably not, right? Because we already have that. So yeah, So block length is BC, which is 0800. DE is start address of VRAM, okay, and then HL is start address of the memory, but that's very low as well, C000. I think it's low, is it? I don't know, it's not. It's this here. It's this. This gets copied into VRAM for a size of 800. It's 2 kilobytes. 2 kilobytes get copied into the VRAM, okay. And we're doing this multiple times, I think. Well, we're doing this. Well, let's see what happens if we cancel out this function though. 6BA0. No, I don't want to break here. I want to break here. Yeah, this one here. 4250. Let's knock that one out and see what happens. So let's make a copy of the ROM. Get the hex editor out. And search for CD-A06B. Only occurs once, so we can just remove that, save, and now let's apply our hacked ROM. And see what happens. So we did remove this function right now. So let's see what happens when we load level 1. We can see something crazy happening. Okay, there's no Lolo. I'm guessing this would be a sprite loading function perhaps. So there's no Lolo, there's no scores, no amounts here, no round number. Okay. And I mean, I can't, are we broken? Yeah, we're broken though. Oh yeah, no, we haven't done it yet. Wait. No, the breakpoint was active. I was wrong here. No. Okay. Yeah, so that function does nothing at all though. That's weird. So we don't seem to lose anything here. That makes it hard to determine what it does though, but yeah. Let's see if the exit works. Yep. Let's see what happens in the next round, if that changes something. So, because now I'm not breaking anymore though. Let's see if it transitions smoothly. Yeah, it does. No clue what that does. Okay, next one. Let's reset to our normal ROM. And go back to load ROM so we can remove this one. And then see what 47FD does. Well, no, let's put it in here. 47FD. Power up related. Okay. Yeah, this probably paints the power ups in the level. There aren't any here, so did it break? Wait. We're not broken. Oh, no, we are. Yeah, of course. So let's see, we load the power up 1, which is in D235. Okay, so we have no power up, so probably not going to do anything in this function. And then the power up state as well. And we're loading a loop iteration variable 3 times because we have 3 power ups, right? So we're going to do something 3 times. We're loading D235, which is 0. We're ANDing it, so we're checking which one it is, I'm assuming. And exchanging, fine. And we're loading A into HL, this D238. That would be our states. Yeah. So we're loading, we're copying these, I'm guessing. And we're switching back, increasing both and jumping, or like loop iterating. So basically we're ANDing, oh yeah, no. It's taking the top whatever bits of the value that was in here and putting it in here, okay, as a state. So the state is indeed a combination of like a tile thing and a state, like, that's hard to comprehend. They're compressing stuff here. So yeah, because we don't have any power-ups, that's going to be hard to look at. So that's the final one of the loop, and then we're loading the power-up state for the first one, and we are returning, yeah. So we have to have a level with a power-up in. That will give us more information, which we can do. I think it was the one with at the end here, level 9. No, yeah, this one has a power-up. Oh, this one, right, so it's 7, I guess. Yeah, this one, yeah, level 8 has power-ups, which aren't drawn yet. So yeah, power-up 1 is 88. Now I wonder, is 88 a tile? That is 136. Is that something? No, right, that's, so 88 is a combination of a state and an ID, the ID being referring to it being a arrow power-up. So it's definitely not a tile ID. It's going to contain, so we're going to copy a part of this 88 into the state. So yeah, we're loading 88, so the address of power-up 1 and its state, which is 0, into, well, the address of the state, okay. We're looping 3 times. We're loading the value of the power-up into the accumulator, which is 88. And we're ANDing it with C0. So C0 looks like the top 2 bits of the 8-bit number. Okay, what is that? That's 80. Okay, well, yeah, I mean, sure, that's the top 2 bits then. It's 1, 2, 4, 8. Wait, let's do C0 and 88. Well, that is 80, of course, because 88 has, of course, only 1 bit here, so that makes it 8, sure. I'm gonna have to look at the other values of the power-ups to see what it actually means, because I think it's separating the 2 first bits here as the type, perhaps, and then the others as a state. Or wait, no, what are we doing with this? So we took the top 2 bits and we are writing this in the state, right? So the top 2 bits are state, because yeah, we're gonna write 80 now in our state variable, and then we're doing this for the next 2, but we don't have any, so that's fine. That's the second iteration. Now the third iteration, and we continue. And so now we're loading this state, which is not 0 anymore, but we have an actual state, and we're calling a function on that. Let's see what that one does. We have power-up 1 state pointer into HL. That's fine. Okay, so we're loading that value, which is 80, back into the accumulator. We're checking whether it's 0. Is that everything? Well, no, it shouldn't. Okay, we're doing nothing if it's 0. That's fine. we're rotating left with carry. Okay, that becomes 1. That becomes 2. And we're ending it with 3. I mean, we're doing some bit manipulation now on this accumulator or this state value. So I'm not sure exactly what that's going to do. Yeah, and we're loading a function pointer here too, so we're adding stuff together. Oh, we're jumping, right. This is complex, and then we're adding it, and we return. So we're doing a check on the state, right? But what exactly, that's unclear at this moment. This shouldn't return. And then we're loading a very low position here. So tile ID is 10. Oh, did we just convert it to a tile position? Oh, right. That could be the case though. And then 341A, which is weird because does that contain the position? But that's a hard-coded number though, 341A. And we'll get a different thing here. Yeah, that's in the middle of nowhere here. So that's fine. But yeah, it updates the tile at position. Oh, that would be this one. Oh, yeah. That could be because that's a hard-coded position, right? That's the location of the arrow inside on the map. So yeah, that might actually be power up 1 position. Yeah. So 341A and then E and then 22. Yeah. So these are indeed so A B. Wait, so we have A B C and D. So we have 4 bytes. So yeah, it might be something though. This is a hard-coded value. So 341A. Yeah, 329D. That might actually be this location here, hard-coded into the ROM here. 3290. Wait, so the Y should increment, but the X shouldn't, right? So and we have 4 bytes. Nah, no. I don't see anything matching here. But fine, that's not super important. We're loading 31 into 8, also very weird. And we're calling something that calls lots of stuff as well. Again, with our D1FF here. Also very weird. Let's escape this one. And I'll do the same for power up 2 state, but we have. So we're calling the same function. That does a check. We're loading the same base address. Oh no, we do load the same base address though. Oh, no, E and A. Okay, no, we are offset. Sure. Okay, but we don't have a second power up, of course. So that's it. Yeah, this handles power up states. Okay, I'm gonna give it a name. 47FD. It is power up related because it's like inside all of the power up stuff. Okay. Then we go back to load round. And let's look what this one does. 45D4. Loads the game mode. Or checks whether we are not in game mode 0. Are we in? We are in type A, I think, so that would be mode 0. C81A. Yeah, so we are in 0. So this function only gets called, yeah, in type B. Okay, so let's load this in type B mode and see what happens, right? Let's reset. Let's type B. And we break here again. And now we should continue. Oh yeah, it does treasure positions. Okay. Yeah, it's going to initialize all the treasure positions in the level. And again with D1FF, which is put onto 1 now. I wonder what that state means. So we're updating, we're doing this 4 times, so we're adding 4 treasures to the level. And we're doing some stuff afterwards too, right? So loading 1 into A, sure, and A into D1FF. Okay, so we're putting D1FF on 1. And we're doing this 4 times. Okay, we're calling something. Again, calling something. Again, calling something. Geez, this is D5. F7. For F, that's an interesting value to fetch. Wait, no, F. Oh no, it's these ones here. B1 for F. Then we are increasing that by 1. Okay, now we're looking at F7. So we are rotating our first value to the right here. And then XORing with the value of HL. And again, increasing it, sure. And we're loading that in D5 F6. Overwriting it. Okay. This is deep into mode B though. I don't know what's going on here. So we're doubling A a couple times and calling the same function, which then changes this too. Okay, and then we are converting, was it 4300 or E14. I think it's placing the treasures, the treasure tiles. I'm gonna look what this one does. I mean, this might be exit door related though. In mode B, I mean. Yeah. And again, calling stuff fine. And we return from this one too. Okay, so we call those two open exit door tile. Oh, these are our duplicates. So this might be mode B related. That's why we have a duplicate perhaps. Because I think, yeah, it has to know this because it has to put the treasures on top of the exit map, exit door. But why would you need a duplicate though? Like, that's weird. And we're looping again. We're probably doing this, yeah, we're doing this 4 times. Okay, that was the last time. And now perhaps placing the tile in the level. Again, doing that 4 times also makes sense. So I'm gonna remove this function and see whether there are still treasures in the map, or whether we cannot, or I mean the stamps, right? The stamps you have to pick up. One more iteration here, and then we're gonna leave. Yeah, and now we're removing D1FF. Sure. Oh, is another map the one with the treasures? CB1E. Yeah, I think this might be the map with treasures though, because 2C, 2D, let's look what those are. This bothers me because that doesn't make sense unless, no, we only have like one, unless it's an amount, I don't know. But this might be these stamps. So let's look what the 2C is tile-wise. That's 44. Oh, it's a heart. That's quite weird. Wait, I'm correct, right? 2C is 44 decimal. That's a heart though. Like, those don't appear in the level. And what we have here, 8, 9, 10, 11. 8, that's the exit door. Okay. And then again, so we have heart. So maybe it uses the hearts as the placeholders for the power-ups, for the stamps, not the, so the treasure stamps. So let's see. And then it needs, yeah, it needs the exit door thing too to place the treasure on top of the exit here. So let's play this and see whether this changes. I mean, oh, they went away. So what happens if I pick up yeah, they do reappear. Okay. So this map does indeed contain treasure related stuff, but I don't know what this 2 does here though. Right, it has another one now. Sure. And another. And that's the 4th. That doesn't change anything here. Yeah, so now let's calculate how much space we have, because this too bothers me, and we need 484 bytes from this one, and I think this is too far down, so perhaps we do start from here, and this is, I don't know. But yeah, this seems like it's either it goes until here, because that's the water flow array, but yeah, from here until here is way too big, so this might contain either start here or contain two maps or something. But let's add 484 bytes to this and see where we end up. So we are at CB1E, and we're doing that to decimal at 484, and go back to hexadecimal. CD02. Yeah, that would be here, and that's definitely not the case. The exit, which is here, does appear to be like at the end of the level. If you go left to right and top to bottom, that's almost at the end. So I think our level stops perhaps here. So let's try from here and do 484 plus this, CB89. Which becomes CD6D. CD. Oh no, that's also not enough. Well, that's here, right? That's in the middle of these though, so that's definitely not the starting point either. But it did reference this point though. That's weird. So if I calculate back from our water flow direction map, CE1E minus 484 is CC3A, so it would be starting from here somewhere. Yeah, not sure exactly. Now let's remove this function and see whether we still have treasures and stamps to collect. So it was this one, right? Let's go back to load round. 45D4. Okay, let's remove that one. Copy over our ROM. Oh, let's reload. Search for CD D445. Only once, that's fine. Removed. Apply the correct cartridge. Let's do that again because it was broken. Okay, now let's try type B. Yeah, so this remained, well, it didn't remain empty, but do we have treasure now? Also, I think that treasure is randomized, so yeah, we do not have treasure at all. We have a timer, but we do not have treasure. Yeah, okay, that's what that function does. It places the treasure stamps in the map. Yep, okay. Let's load the regular ROM. Yeah, 45D4. 45D4 next to a type B function. So yeah, that's good. 45D4 means initialize type B treasure locations. And then what do we do then? We're putting the current level in D2, D4 and the game mode in D2, D5. Okay, so those are now unknown, but apparently these are copies that we use somewhere. Okay, and then D6 gets HL. So let's see what these are, right? We're going to load level 1. So current level is C81B. Let's look in that area. C81B. Right, these are a bit confusing indeed. And we're going to write this C81B, which is current level. We're writing this in D2, D4. D2, D4, which is garbage now, I think. So we're going to write the current level, the game mode to 5, and then HL to D2, D2. Yeah, so we have these 4 bytes are going to be overwritten, and what is in HL D238 is currently in HL. Well, no, let's see what happens. So A into, yeah, that's this one. This one then means current level dupe. I mean, it's weird why we have to copy this, but sure. No, we need to go to D2. D2. These aren't sorted either. No, here it stops. D2. 6, 6, okay. D2, D4 is current level during initialization. And then 5 is given the game mode, current game mode. Okay, and then, so let's reload so we can see those. Yeah, these two we have, and now we're going to load these two. So we're loading D2, D6. Wait, that's weird. So we're loading that into HL, right? Okay, that's now a pointer to these two here, and it's going to write itself to, like it's writing its address to its value, right? Because now we're writing D, like D2, D6 into what D2, D6 points to. Weird. Oh, we're still on D2, D6. So we're loading 1 into what HL points to. Oh, wait, D2, D6. Oh, yeah, that's a different one. Wait. So yeah, we're loading the hard-coded value of D2, D6 into HL. Oh, yeah, D2, D2. Okay, wait. Why would you do that so complicated? Like, so it's using D2, D6, which is this one, and D2, D2. So D2, D6 contains a pointer to this memory location, and that's where we write whether it's a demo mode or not. Well, no, No, but it's normal play, because if we have a demo mode, we skip this write. And then we're writing 0 in D219. Okay. So let's look at D2D6 is demo mode related or non-demo mode related though. Okay. And then, okay, so we're removing A and writing that in 219, and then we're doing our game. So that's good. Now I do wonder, okay, D2D6 gets changed already as soon as I start walking, and doesn't change anymore though. Weird. Okay, I'm gonna wanna see what reads this value. So I'm gonna restart here, and right. So this still points to D2D6. Maybe this points to like the subsequent values in different levels, because we're still in level 1, right? So that could be incremented, like this could be incremented to D2, D7 for the next level, and 8 and stuff. So let's see, let's let this go. Right, so we're doing this now. Also, can I change this? No, that doesn't. Oh, wait. Oh, no, that's fine. It's counting down these sequentially though. What is this? I'm gonna restart because I did change that value before start. I'm gonna let it do now as it normally does. Yeah, this counts up and this counts up. Now they all count up. Okay. They all count up to OF. And do they, wait, does it start from, no, it's just, this is bogus data. Okay, so, but it starts counting from 1 to OF. That is weird. Yeah, this pointer does change indeed. Yeah. So, well, not this 01, but yeah, this pointer is incremented every 15 frames because we're counting from 1 to OF. Let's see what this does in level 2. I'm curious about that. So we're pointing again to D2D6, which is this one. We're in level 2. Game state is type A. Game mode, yeah. Game mode is type A. And we're going to start counting again, I guess. So we have written 1 into D2D6. That makes sense. Or I mean, that's what happened. And then as soon as we move, these start counting down again. Yeah, this pointer keeps going up. I do wonder if it's going to reset. I mean, worst case, we have to wait until this one here, right? I mean, yeah, that's going to take quite a bit, but I am curious. Of course, we can see what reads this, though. Because some masking is going on here as well, I think. Can we knob something out? So we don't need this one. Was it this one? 02459. Oh no, we cannot though. Yeah, because we loaded these values and it started working. So unless we knob out this, perhaps putting one into HL, in other words, putting one in this. Yeah, if we do knob that out. Wait, so what do I want to achieve? I want to prevent one being put here, which I can just do while breaking row. I don't need to change the ROM for that. Okay. Let's see. I mean, it's halfway, I guess. Also, this one appeared as well. Why would they be counting to 15, like, and use all this memory? So we are not doing this if we're in demo mode, right? Because we are jumping to 4273. So yeah, we're not putting one into D2D2. No. We're putting. Wait, where are we? Yeah, we are putting D2D6 into D2D2. So that's the starting pointer. Okay. Then we're checking whether it's a demo mode or not. If it is, then we skip putting one into HL, which then points to. It still points to D2D6. Okay. Yeah. So demo mode prevents this from starting to tick, or wait, it stopped. Did it? What could that be? Like it did stop though. So the pointer isn't increasing anymore. This is still on 1 or 51 or whatever, and it stopped. Very weird. And it doesn't do that in demo mode. Because if we go to demo mode, or is this the counter to start demo mode perhaps? But no, that would just be a simple timer, right? I want to go to the main menu. So this memory isn't reset at this point. I'm gonna wait for demo mode and see what happens here. It is initialized to D2D6, but this value isn't overwritten. Oh, we're broken. Okay, sorry, wait. So yeah, we haven't put a 1 into HL, which is pointing to, well, D2D6, which is this one, but it contains garbage though. Or is it? So if we play now it counts down here, but this whole thing doesn't do anything. Wait, so the pointer is taking up. Wait, D2, DD. Yeah, that's okay, sure. So it is indeed going through the routine of incrementing this pointer, but it's not. And like functionally, wait, yeah, that's it. That did say around 8.6. Are these the? Okay, I think I know what this is. I think this is the recording the movement recording for the demo. And of course, if you play a level, then it will record into inputs into this array. So yeah, so let me try to just play a level here. And I think it's going to start updating these values instead of 0f. It's going to track my movement, I think. Yeah. So it is updating the pointer. And it is like, it is doing, yeah, this is the recording. Huh. And every time I change my direction, it goes to the next one. So but what could it be? I mean, okay, what I immediately see is that the direction is the top 4 bits of the byte, because 3, 1, 5, 7, yeah, those are directions and tick counts. That's crazy. So yeah. So this means, so we have our directions, right? So we have 1 is up for 9 ticks, 7 is left for 5 ticks, 5 is down for F for like 15 ticks. So it saves like, or 16, I guess, it saves the ticks. And over here it stops because the demo has a limited time. So they only need like 16 times these amounts of bytes. Unless that's even, perhaps this value is the length, perhaps. No, but that was D2, D6, right? It's probably going to go to here. So 1 is up, 5 is down, right? 1 is up, 5 is down. And you can see that in the values that are changed. 1 is up, 5 is down, 1 is up. So these 1s, 5, 1, the starting number, I mean, does change to the direction. That's pretty efficient. Okay, so yeah, and the moment you change direction, it goes to the next, obviously. So what happens now? We're almost at the end here, unless this is all available for, yeah, because the hard-coded data is the solution for the level, for the standard demo level, which we are now overwriting because if I wait now on the main menu, this will replay what I'm doing right now. It won't replay the, oh yeah, it just keeps going. So we have quite a bit of space to record. Oh wait, no, we did stop. Wait, what happens now? Oh yeah, no, it did stop. So until here then. I wonder, I mean, if that's all we do. Because I mean, yeah, the demo has a limited length of time, right? So then it just resets to the main menu again. So we only need a certain amount of frames. So if you multiply from here to here by 16, you get the total amount of seconds, I guess, if you convert frames to seconds. And I'm betting that one of these guys, perhaps this one, is the level. Well, no, of course, this is the level and the game state. This is the level to play. So if I change this to 50, it's now going to play level 50 in the demo. So I'm going to use the keyboard to stop to go back to the main menu. And then we're going to wait. So it starts the demo again. And it's going to start at level 50. Of course, with my stupid inputs here, that's not going to work, but it is going to level 50, I think. 50 is at 80. Yeah, 50. So all over the place they do the level numbers in BCD, and here then they don't. Okay, but yeah, so absolutely. So if I do 49, that would be 73. Yeah, that does make sense. Okay, so this is we're gonna rename this, right? So this is demo level, and this is demo mode, and then we have an array here. So wait, did that value get initialized though? Let's see. So we start the pointer at D2, D6. That does make sense. Oh yeah, so this is D2, D2, and 3 are pointers. Oops. So this is a pointer to demo movement recording array. Pointer is incremented every time you move or change direction, which is not 100% correct either, but that's fine. So yeah, we have 2 pointers, 2, 3, 4, 5, so that's known. And then this one was 1, 2 at a certain point. And then we just have the data, right? D2, D6, we don't write anything in there. Or we write 1 in there. Oh, would 1 mean start recording? Because we don't do that when it's in demo mode, because we don't re-record whilst playing the demo mode, right? So we skip over this one. Wait, so let's play a game here again. Let's reset to the start of level 1 here. Level 1 before start. Okay, so and it does load, of course, the entire instructions for this demo level. I don't know. It's level 56 hex, which is indeed the level. I think it is 80. Was it 80? No, that's 86. That's the demo level, right? In mode 1 or in type A. Yeah, so let's save this. Let's reload the symbols. Okay, and then, so we do write 1 in there. Wait, okay, I lost my function here. We do load 1 in here, so let's remove those guys. Yeah, so we start and we write 1 in the first position. Right, so we do, I think this means start recording. Because if I put this on 0 now, I don't think we will be recording. We still might, not sure. Okay. Yeah, no, we do record. So does this mean do recording then? Nope. It's still recording. I don't know exactly why it writes 1 in there. Unless, okay, let's try running the demo mode, but actually putting 1 in there. So not skipping our jump here. Yeah. So I'm gonna wait for demo mode. It's going to have to stop here. Because otherwise, I mean, this is not gonna break, right? Because we are in demo mode. Right. So I'm not gonna take. I'm gonna take the jump, but I'm gonna execute this line manually by putting 1 in here, and let's see if it re-records the values. So I'm gonna continue. Oh, it's confused. Well, yeah, it lost its first thing though, because that was supposed to be 12, right? So it's executing its thing, its positions here. So I don't know exactly why it puts 1 in there, but fine. So let's give this a name too. D2, D6 is demo movement and timing array. So this contains directions and no, it's directions. It's not, and timings recorded for the demo. Top nibble of bytes is direction, and bottom nibble of byte is ticks to move in that direction. It would be handy if I could put like an array of stuff here though, so it's because now it only will highlight the first one. But yeah, I would prefer it to highlight the entire span of data. Because yeah, it supposedly stops here. That was the end point, right? So let's see how many bytes that is. D3A minus D2, D6, of course. Oh, 64, that's 100 bytes. Wait, we were 64 hex, yeah, that's 100 bytes, of course. I mean, I could add them, of course. But yeah, that's a bit... I'll have to write something that creates a symbolic file, a sim file from like an instruction that says, okay, just assign 100 bytes here and give it this name. Yeah. Okay, so that's known now too. And I think this may be unused, not sure yet. Okay, let's reset because I think this byte might be the current one we're handling, perhaps. Because it doesn't change, right? Yeah. So it doesn't change the values here, but it still has to tick down a little timer. So I think if we start the demo here, right, and I'm gonna pause. Well, it's 0 now, 71. Do we see a 71 here? Well, I mean, the first number here should only be 1, 3, 5, and 7. Is that the case? 5. Yeah. I mean, it's literally 3 and then right, and it's ticking down. Yep. So this is the current movement and direction we are handling, and 0 means stand still. Wait, how does the standing still apply though? How is that recorded? Because we track every length, but not standing still. Oh, it's counting. It was standing still and it was counting down from 9. Okay, but let's just record our own then. That's very simple. Oh, yeah. Of course, there's a 0 at the start. Yeah. Yeah, of course. So if I move down, it's down. So 5 is down and it counts up. And then it's just, now I'm doing nothing and it's just 0 at the front. So yeah, 0 is obviously moving, no movement at all. Yeah, that makes sense. So this one is replay, current, direction, and timing, and timer. That's D2CF. So this is demo replay, current, direction, and timer. Okay. Now we don't know what this one means yet. I mean, it's going to be replay related. I mean, it is record though, because it stopped recording when it was on 0, and now it starts recording again. Oh no. Oh, like it stopped counting when I didn't move now. So it gets, oh wait, it gets reset. Yeah, of course, it gets reset to 1 when I start moving again, obviously. So that means that if we load our level, that would be 0 when the level hasn't started yet, and it will become 1 when we are when we activate a level, which also makes sense. Now I wonder though if I think that was 1 during demo mode as well though, which doesn't really make sense. Oh no, it's actually 0. Yeah. Does that mean I can take over now? No, of course not. Yeah, so this probably isn't even looked at when you're in demo mode. But yeah, this should record or not, right? So D2D1. Is okay. I don't know what this one is, if that even changes. I'm not sure, because this one is right at the end here. Like we're missing some data for sure. But yeah, this entire array, I mean, I could add it though, like so that they're all brown or like known. So let's see, where are we? I can do this. 0 to 99, I guess. I mean, sure, why not? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we still have some D's. 7, 8, 9. A, B, C, D, E, F. what exactly is a 0? What did you mean? I don't know what you're exactly referencing. I probably wasn't looking at the chat. Something about, oh, no, I was looking what happened. So you have to record movements, right? If you're recording the demo and it recorded the direction. But what would happen if you don't record when you're not moving at all? But it was simple, of course. The direction would just be 0 and it still counts down, right? It's like your time counts down. So that it didn't make sense. I just forgot about the direction being 0, meaning there's no movement at all. So simply that. Well, it's not going to be much F here. E, F, and then it's... Wait, where are we now? So that's 3-0, I guess. Yeah, should be right. 2F, 3-0, and then these guys. Wait, no, this is also 3-0. Yeah, I didn't think I could figure that out, where the demo stuff was recorded or something. But yeah, it did pop up in our investigation anyway. So yeah, I hope I'm not making a mistake here. We need C, D, E, and F, and then we are at 2. Okay. Okay, come on. Oh, the stupid thing is auto-completing for me. That prevents me from... Wait, are these known already? No. And then 8, almost done. 6, 7, 8, 9, A, B, C, D, E, F. 90. Wait, did I make a mistake? 1. Yeah, I did. Crap. This needs to be 1. Oh, no, wait. I didn't make a mistake. It should be 2, right? So 1F becomes 2-0, that's correct. 2, A, B, C, E, F. Okay, yeah. So this becomes 3. Okay, and then the last one. Oh, no, 99 is the last one. Okay, now let's see. I forgot. I did make a mistake. Of course I did. At D2F3. Oh, yeah. This should be E. And then we go, oh, crap. This should be 2F, right? Yeah, E goes to F. So we're too far down. No, we're not. And that, oh yeah, it's like this, I think. Wait, so, oh no, we are at the start, we're wrong as well. Wait, no, we start here, D2, D6, right? That's 0, 1, 2, 3, 4, 5, 9, 10, 20. Okay, we're missing 30, 29. Jeez. Okay, why did we do this? Okay, this needs to be automated. That's why. So F3. This needs to be F. O F. So we have. Oh, okay. We have duplicates, of course, because this now becomes. 30, right? And this becomes 31. No, that's correct then. Okay. How does this look? Okay. 0, 10, 20, 30, 40, 50, 60, 70, 80, 99. Oh wait, did we start at 0? Yeah, we did. Okay, that was silly work, but sure. We have now our little array fixed. I think I saw it writing in this one too, though, which would make it 101 positions. That's a bit strange, but sure, that doesn't really matter because there's nothing clearly used here, unless we see something there later on. That's fine. Okay, let's look back at our initialization function, our load round function. Yeah, so that's not really a function. D219. Yeah, that's this one. Is put 0 into. That looks like a counter, right? Does this flicker around quite a bit, but let's see if it also works in a level, whether it also does that in a level. I mean, it looks like I guess it starts from 0. Yeah. So now it just counts to 5 or something, I think. Does it move when I start a level? No. I'm not sure what that. I mean, it is just initialized to 0 here, though. At this point, D219 is just put 0 into. I mean, I guess we can take a look. I'm curious if we go see when that's being written in. Was it no, to 19? So this function starts here. We're loading 2 into, oh, new D002. Also an unknown. That's this one. We're loading that one. We're putting 1 in there, sure. 219. We're increasing. That's the one we were looking at here. And then the next one, also increasing. So 19 and 1A are increased. Okay, so I want to know what happens if I don't do that. So I'm going to remove this function. So it's 6C78. Let's escape this function. Okay, that's farther up. That's unfortunate. Okay, that sucks though. But it is this one though. I wonder why we can't. Do we have return here? Yeah, we do. What's on the stack? Let's see what's on the stack when we remove this, or when we exit this function. Okay, we're doing weird stuff here. Okay, that's why it also interesting. So we're calling something, popping the thing BFB8 into the accumulator, and we're jumping. Oh, okay. Okay. Yeah, we can't jump over that. That's just a return. Wow. So F392 is our original call position. Yeah, F392. That makes it hard to jump out of that. F398. Oh, and it jumps to a value in the IX register. That makes it very hard. But fine, let's continue. I don't know what these two values do though. That's annoying, and they also only seem to be checked here, but at one other spot as well, right? I mean, I'm not be able to force it. Yes, can I? Yes, over here as well. So it is maybe input related, keyboard input related, because now we are loading 0. Oh, that's probably when the value reaches its maximum. So D219, yeah, is now 0. Okay. Is this a wait function for keyboard input, perhaps? Like keyboard debouncing? That could be the case, though. Because over here we're using D219. Okay, so yeah, we're loading the yeah, we're comparing it with 6 and JR. I have to look up JR exactly. So we're not making a mistake here. JR of C and then a pointer. Right, that's this one. If the carry flag is set, then we're jumping. So it only checks the carry flag. Yeah, this is keyboard debouncing, I think. Okay, let's test that. By increasing this value to FF and see whether we are whether we can move instead of every 6 frames, every 255 frames. Yeah, let's try that. Let's see, I'm gonna write down where I am because I don't want to lose that. We're looking at the comparison at 43E5. So let's open the hex editor. And we are searching for 7E-FE0638DC. That's not found. Did I type it wrong? 7E-FE06. Okay, that's multiple times found. 0638DC. That should be in there though. Okay, that's only one time. Yeah, only one time. So it's this 06 that we're comparing against. Let's change that into like AA. Okay, let's save that. Let's apply this ROM to our game here. So we're going to load the hacked ROM. Let's see if that affects debouncing of the keys. So let's go to D219. Oh, no. Good that I wrote it down. 43E5. Yeah, so it's comparing now. Yeah, with AA. Our comparison is here now. Yeah, the demo is already messed up, and you can see what happens, right? The debouncing, yeah. Oh, and it's for the entire game, I think. Yeah. Okay. So I'm probably gonna have to. I mean, it's gonna take a while now. Oh no! So this is normal debouncing, but what happens here? So I'm pressing down, and it's not activating. Okay. Yeah. This is key debouncing. I'm holding the key down now, and it's awaiting AA, which is quite a bit. Yeah, 170 frames in between checking for keyboard inputs. So that means that this timer here, which is counting down from AA until 0, this is the keyboard debounce timer. Now I don't know why, because we have a similar one here though. This one counts up for some reason. Is this referenced here too? Not really, but we can look at that one next. So D219 is a keyboard input debounce timer, 6 frames debounce. Okay, so we know that one too now. And this one counts up, right? So let's see what happens if we mess with that one. I'm going to go back to the normal ROM. Okay, let's see. Yeah, okay, so this counts up until FF from 00 to apparently FF. Yeah, and this one only from 0 to 6. I'm gonna start a level to be certain and see what writes here at D21A. Activate. Oh yeah, it was wait, so this writes 1 into where the HL is pointing, which is pointing at D002. Okay, that was all the way up there. Then we load the input debounce timer and we're increasing it. This counts up, right? Or does it count down? It's 6, no, it's 4 now. Let's tick. Yeah, it counts up. They both count up, and 6 and goes back to 1. So it's 5 frames. It's not it's 5 frames of debounce. But then the next one is unlimited, as in it overflows when we reach FF. It just overflows to 0. Why do we need this one? So actually we need a read thing here, a read memory instead of a write, because we're not interested in reading this or in writing to this. That's just going to increment, right? So we need a read pointer here. Okay, this does get checked. Oh, is that right? Could that be bullet related indeed, as in bullet speed flying on screen, perhaps? Like this could be an animation timer of some sort. So, okay, we're loading the value of our crazy timer here, D21A, into our accumulator and checking whether the top, bottom, or the bottom 2 bits are set, right? Because we're ending with 3, which is 1100, right to left. Is that the case? It's not. So next one, is that the case? It's not. Oh, and that's in the call, in the handle keyboard input function. Okay. Is it now? It's not. Probably now then. Nope. So BA, no luck. Oh, it's still BA. Wait, why is it not? Now it's BB. Oh, did it call it that many times? Yeah. So we are reading and increasing, fine. Now it's BB. Let's see, BB. Yeah, that should, I mean, if we AND that with 3, that should be matching here, because the 2 top bottom bits are set, so we shouldn't jump away now. And we do. It's still BB. Wait. Oh no, okay. And now it's BC. Does it work now? Yeah, okay, so wait. So that doesn't really make sense to me because BB has the bottom 2 bits set. Oh, it's NZ. Okay, sure. They shouldn't be set. Okay. Right, makes sense. Neither one of the bottom 2s may be set. Okay. So we're loading the flying bullet state, and that's not gonna be so that's not gonna happen because there is no bullet on the screen. So we're probably gonna return now. No, we don't. Oh, so it doesn't happen if there's a flying bullet. Okay. And there is no, okay, so that one does fail now. Is egg flying on screen? So this only happens when the egg is flying on the screen. So let's break here and let's disable this one. Okay, I'm gonna give myself some ammo so I can shoot this snaky at the bottom here. Let's see, it should break from the moment I let this, so not now, but when I fly it off the screen, then it breaks. Yeah. So that is what this timer does, right? Fetch snaky, respawn an X state data pointer. What is our timer on now? We are looking at this one here. Actually, now I want a write. Well, no. Question is it still going to read it after this position though? I think this might just be a general timer, and in this case we are checking whether the 2 bottom bits are unset. Like we're only doing this for like every n amount of frames. This might also have something to do with like time synchronization, as in converting frames to seconds or something, because we have to start our timer here, right? Our timer for it, first of all, shooting off screen, and then the countdown timer for respawning. So yeah, let's see. Okay, we're loading. So we have the pointer. I think it's in IX fetch snaky respawn and X data pointer. Where does that save that? Yeah, IX and IY. I have to. I mean, I think I didn't document that. I should add that. Fetch snaky respawn and X state data pointers. Okay, it returns here. Yeah, so IY contains the XY or the YX positions, and IX contains X state for snakies. Wait, why snakies though? Because we can do the same thing for other monsters as well though. So this might not just be snakies then. Okay, IX being the X state. We're not moving it yet, so this is probably a collision function between the bullet and the egg. Yeah, probably. Okay, so we are loading into the accumulator the X state, which is going to be non-zero, right? That should be at least. Well, no, it is 0. Why is it 0? IX is D113. It is 0, and that is snaky 1X state. Oh, because it's probably not yet as in an X state. That's a bit weird. It's compared to 4, which it isn't. Increasing IX. that would make it... Oh, it's looking every snaky, because now it's pointing to D114. Okay. Wait, but this is too complex. I think we're just looking at a general timer, so I can't really put a thing on there, because the only thing we were looking at was this AND function here, like this AND. So what I'm gonna try is going back to the writing of this timer and see if we can remove that. Right, so instead of incrementing here, we're going to do nothing. So this timer will stop, and then we'll see whether that affects the shooting of the bullets or the shooting of the egg or whatever. Yeah, so we're going to knock out this one. We're going to look for 21180-234. Okay, so it's our 34 here. That's the increment instruction, which we are going to remove. Save that. And now if we load our hacked ROM, let's see what happens. So this crazy timer here should not move anymore when we load our other hacked ROM. Question is, does this affect respawning or maybe other stuff in the game too? I don't know. At least this still works. So what's weird is that this in the menu, this one counts up to way high. Okay, but that's okay. Now it's just a 6, and this one stays on 0. That's what we wanted. If we go look at our break, well, no, I didn't save it, of course. Well, no, I can't do that, right? Because now we're not writing it anymore. So yeah, what happens now if I shoot something? Get some bullets. Can I shoot? I can shoot. Okay, so maybe it's egg thing related. I can do that. Ooh, that was very quick. That was very quick. That shouldn't move that fast. Let's go to another level. Oh, so yeah, the respawning wasn't affected either. It's just it affected the speed of the egg shooting off screen. Question is, does it do anything else though? Let's see. Where can we shoot something? I guess in this level, right? Yeah. Okay, and now that's, oh yeah, that's normal because we're not in the hacked level anymore. We have to load the hacked ones here. Yeah, so now it should fly off. So that was quite slow when it moved off screen, right? So now if I do it with this one, oh, it doesn't even want anymore. Okay. Okay, now it's broken because yeah, I can't shoot anymore. Like it's in a state. That's weird. So I think this is like a timer for moving that egg off screen. So this is normal. This doesn't do anything anymore now. Okay, something put 16 in here though. Okay. Interesting. So I'm gonna shoot something. this one became 1 too. Okay, I'm gonna remove this egg now. Okay, never mind. Okay, I'm gonna shoot. It's off screen. It's weird that it stopped. It didn't do that the first time though. Or does it have to be? Oh yeah, it has to be 0. That's probably what's going on here. Yeah. So this timer counts up constantly, right? And it has to return reach 0 for the egg to shoot off the screen. So if now it won't work. So I'm shooting it. Well, okay, it did work. Fine. Crap. It's not that then. Okay, it's the bottom part of the byte. Sure. So yeah, I think this. Yeah, wait. So I'm putting it on 0. Yeah. It's the bottom part has to be 0. I think it has to be 0. So let's see if it's another value works. Oh, it counts it down. So it counts down the bottom part. I don't know what the top part does then. Okay, so this has to count. Well, it counted down though. That's. Oh, wait. I was looking at the wrong one. Okay. Yeah, no, it's the bottom part. Yeah, of the timer, not the one next to it. I was looking at the wrong one. So if I put this on 50, the bottom part is 0. Yes. Yeah, so it goes. Oh, if it's higher, perhaps. That could also be the case. Okay, no 5C works. I mean, it's going to be bit related, I assume, though. Like, so if I look at 5C, 5C worked. 5D doesn't. Of course, that only changed the first bit, right? 5C and D, yeah, of course. So is it the bottom bit, or is it odd and even numbers then? If I do 5E, what would that be? No. 5F, and then 6-0, so 5 nor 5F and 6-0. Is it the bottom 2 bits? So that would make it 1, 4 would work, and 5 wouldn't. Does that make sense? So 5 would not work, and 4 would. Yeah, it might be the bottom 2 bits that influence whether it shoots off or not. But okay, that's fine. I don't think it's related to anything else. I mean, I'd have to trigger it, of course, right? So unless we go on read, yeah, it's always here, like it's always in the bullet thing. So I think that is just a timer specific for the bullets. Okay, let's give it that name, D21A. This would be shoot egg off screen timer as if bottom 2 bits are 0, 0, then it shoots off screen. Yeah, I think it's related to that. Oh, of course. We are checking the two bottom bits. The two bottom bits have to be 0. I wonder why they did that specifically. Like to introduce a small delay, I guess, for the egg to shoot off. Because if you look, that's what happens, right? So wait, disable this. So I mean, it's hard to, well, no, did I knock it out? Are we in the hacked one or, wait, let's go to the normal one to be sure. This is the normal ROM. It's hard to tell whether there's an extra delay before it moves, but I guess it's fine. It's fine. So we have our two little timers here. Let's look at our level initialization again. No, we still have that one. Yeah, load round. Okay. What do we have still? Yeah, we found the demo movement recording array, and then we jump in the, or we fall through into the game loop, right? Which runs indefinitely. I am going to check who calls the load round function though, but that might end up in the main menu function. Let's see if we can do that. Okay, there's no value on the, no return value on the stack, so we can't return from this function, unfortunately. Do we have something unknown in, oh yeah, this one I wanted to look at, because that's a BIOS function that I didn't know, but now I can find this out. Oh, that's weird. I don't know what this does. Oh, music. Wait, what is the PSG? Programmable sound generator. Okay, this initializes the sound. Okay. Right. Right, because the music has to start playing. Reinitialize overall game state. We're setting zeros in and FFs in lots of variables that we don't know yet, so we have to figure out these as well. DD54, that's quite low down. yeah, like for example, this one gets set to 0. But yeah, we'll have to figure out what that one does too at some point. But that will be for next time. So thanks for watching, and we'll pick this up next time. Okay.